In everyday language, a person utters a tautology if he or she says something which is true, but only because of its form, such as, it rains or it doesn't rain. Ordinarily, uttering a tautology sounds a bit silly. It is like saying something which has no content. On the other hand, in a conversation, a person may say something which at first seems clever, but in closer scrutiny turns out to be a tautology, such as, if Caesar built a bridge over the Rhine, then Caesar went to Gaul, or Caesar built a bridge over the Rhine. Despite this negative reputation of tautologies in social contexts, it is of utmost importance to be able to distinguish between a tautology and a non-tautology. For large formulas, this is so difficult that finding a good algorithm for it is a famous open problem, called the P=NP problem. Tautologies can help us squeeze information from known facts without acquiring new data. In simple cases like the above Caesar example, this may seem superfluous, but when the formulas are complex, it is not so easy anymore. A propositional formula is a tautology if its truth value is 1 under any valuation. This can be checked with the truth table. Examples. The following are examples of tautologies. Left parenthesis, P0 or P1, right parenthesis. If and only if, left parenthesis, P1 or P0, right parenthesis. A or not A. Not, left parenthesis, A or B, right parenthesis. If and only if, left parenthesis, not A and not B, right parenthesis. Not, left parenthesis, A and B, right parenthesis, if and only if, left parenthesis, not A or not B, right parenthesis. Left parenthesis, A implies B, right parenthesis, if and only if, left parenthesis, not A or B, right parenthesis. In each case, one can draw the truth table to see that the formula is a tautology. A formula is satisfiable if its truth value is 1 under some valuation. This can be checked with the truth table. Uttering something which is satisfiable is like saying something which could in principle be true. For example, if I say, it rains but it is not snowing, I may be right or wrong about the current weather, but surely it could be the case that it rained and at the same time did not snow. Likewise, the sentence, the train is moving and the door is open, seems by all means satisfiable, for we can imagine a situation, perhaps undesirable, in which a train is moving and someone has left the door open. In propositional logic, we can decide the satisfiability of a formula simply by examining the truth table of the formula. Examples. The following are examples of satisfiable formulas. Left parenthesis, P0 implies P1, right parenthesis, and not P0 and not P1. Left parenthesis, P0 or left parenthesis, P1 or P2, right parenthesis, and not P0 and not P2. Not, left parenthesis, P0 or P1, right parenthesis, if and only if, left parenthesis, not P0 and P1, right parenthesis. In each case, one can draw the truth table to see that the formula is satisfiable. A formula is contingent if its truth value is 1 under some valuation and 0 under another valuation. This can be checked with the truth table. In everyday language, a contingency is something that may be the case, but most likely is not the case. An airplane may lose one engine and still fly safely, but losing two engines may have catastrophic consequences. For such a contingency, the pilots probably have special emergency routines to follow. In propositional logic, a contingent formula is one that is satisfiable, i.e. may be true, but also the negation is satisfiable, i.e. the formula may also be false, with no concern as to which possibility is more likely. Examples: left parenthesis, P0 implies P1, right parenthesis, and not P0 and not P1. Not, left parenthesis, P0 implies, left parenthesis, P0 implies P1, right parenthesis, right parenthesis. Not, left parenthesis, P0 or P1, right parenthesis, if and only if, left parenthesis, not P0 and P1, right parenthesis. In each case, one can draw the truth table to see that the formula is contingent. A formula is refutable if its truth value is 0 under some valuation. This can be checked with the truth table. In everyday language, a refutable statement is one which may happen to be true, but can certainly be false. Like, if it rains, then it blows from the west. A teacher may yell at a student, "Either you are late, or you have left your books at home." But the student may reply, "2 days ago I was on time, and I had all my books with me." So what the teacher had said was refutable. When someone makes a statement claiming that it is a universal truth, he or she may prompt a person present to point out that the statement can be refuted and therefore cannot be a universal truth. In propositional logic, refutability of a formula has a technical meaning. It just means that there is at least one valuation, row in the truth table, which renders the formula false. Examples. Here are some refutable propositional formulas. Left parenthesis, P0 implies P1, right parenthesis, and not P0 and not P1. Not, left parenthesis, P0 implies, left parenthesis, P0 implies P1, right parenthesis, right parenthesis. Not, left parenthesis, P0 or P1, right parenthesis, if and only if, left parenthesis, not P0 and P1, right parenthesis. In each case, one can draw the truth table to see that the formula is refutable. In everyday language, a person utters a contradiction if he or she says something which is false merely because of its form, such as, "It rains and it doesn't rain." The contradiction may be more hidden, as in, "It is not that it rains or it blows, but it certainly rains." In a conversation, a person may make a statement which others find controversial, and the statement may be under fire from all directions, but if the statement turns out to be contradictory, or in contradiction with something else that the person has just said, the statement is not taken seriously anymore. A propositional formula is a contradiction, or contradictory, if its truth value is 0 under an evaluation. This can be checked with a truth table. Examples. Here are some examples of contradictions. Left parenthesis, P0 or P1, right parenthesis, and not P1 and not P0. A and not A. Left parenthesis, A implies B, right parenthesis, and A and not B. Left parenthesis, A or B, right parenthesis, and not A and not B. In each case, one can draw the truth table to see that the formula is contradictory.